Hello, good morning everyone. My name is K. Vidyasagar. Okay, today we are going to discuss about the P block elements. The second year, fifth group elements we are going to discuss now. Okay, right. Now, fifth group elements. Okay, right. The fifth group elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. So about these group elements we are going to discuss now. Okay, right. Now first one, these group elements occurrence will discuss. Occurrence. Okay, right. In occurrence, nitrogen actually available in the form of diatomic molecule as a gas. 78% is present in atmosphere. Nitrogen available in the 78% present. Okay, and the nitrogen available in the form of NaNO3 as well as KNO3. The nitrogen available in the form of NaNO3, sodium nitrate. You know, which is called, this is called chili saltpeter. Chili saltpeter. KNO3, which is called, you know, Indian saltpeter. Indian saltpeter. It is called Indian saltpeter. Okay, so nitrogen available in the form of sodium nitrate as well as potassium nitrate. Okay, right. And then we're going to discuss about the phosphorus. Phosphorus available in the form of hepatite family. Hepatite family. So hepatite family. Hepatite family. Hepatite family. So in the hepatite family, general formula Ca9, PO4, taken 6, CaX2 dot CaX2. This is a hepatite family. Okay, here phosphorus is present. Okay, and here X is equal, you are going to take chlorine, or OH also you are going to take. Okay, so hepatite family containing one best example, fluorapatite. Fluorapatite. Fluorapatite formula Ca9, PO4, taken 6 dot CaF2. This is the fluorapatite. So phosphorus available in the form of fluorapatite. Okay. And the next we are going to discuss about the arsenic, antimony, and bismuth. You know that these arsenic, antimony, bismuth, these compounds are available in the form of sulfide minerals. So these three compounds are available in the form of sulfide minerals. Sulfide minerals. Okay. So this is the occurrence of the fifth group elements. You know the important points. These fifth group elements are called nitrogens. What are these called? Nitrogens. Okay. Right. Now we are going to discuss about the electronic configuration of fifth group elements. Electronic configuration of fifth group elements. Okay. Fifth group elements general electronic configuration. You know what is that? The general electronic configuration NS2 NP3 electronic configuration. What is that? You know, NS2 NP3 electronic. And you remember, this is the most stable electronic configuration. Most stable electronic configuration. Why? Because the p orbital electrons are half-filled electronic configuration. That's why this electronic configuration, we can say that most stable electronic configuration. Okay. And the next we'll discuss about the atomic and ionic radii. Atomic and ionic radii. Atomic and ionic radii, down the group increases. Atomic and ionic gradient, down the group increases, down the group increases, down the group increases. Why increases? You know the reason. Why? Because the differentiating electrons enter into the new shells. So that's why the atomic and ionic radius down the group increases. Okay, and now we are discussing about the ionizational potential. Ionizational potential. Ionization potential. Ionization potential of these fifth group elements are very high. Why? Because you know the reason. So just we told it having the, what is that, you know, most stable electronic configuration. So ionization enthalpy is influenced by the half-filled or full-filled electronic configuration. Now this fifth group elements half-filled electronic configuration is having. So that's why most stable electronic configuration. That's why I'm telling that ionization potential of fifth group elements high compared to fourth group as well as sixth group also. What I'm telling you, understand? Fifth group elements ionization potential is higher than even compared to fourth group as well as even compared to sixth group also. Fifth group elements ionization potential is high. Okay, and you know that ionization potential down the group decreases. Ionization potential down the group what happens? Decreases. So why decreases? Because of atomic radius increases. That's why ionization potential is decreases. Okay, right. This is the information about the ionizational potential. Okay, and the next we'll discuss about the electronegativity. What is that? Electronegativity. Okay. Electronegativity also down the group decreases. What happens? Down the group decreases. Electronegativity down the group decreases. Okay. Because of its atomic radius increases as well as metallic character also increases. Due to these reasons, electronegativity is increases. Okay. And the next we will go and discuss about the physical properties. Physical properties. Physical properties. It means that this fifth group element physically how they are. Physically how they are. See, nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, now see, actually these all fifth group elements are, okay, polyatomic. What is that here? All fifth group elements are polyatomic. Except to nitrogen. Nitrogen is a diatomic gas. Except nitrogen. So then what is the nitrogen say? Nitrogen is a diatomic gas. Nitrogen is a diatomic gas. Okay, so I knew here nitrogen only gaseous state, and remaining elements, phosphorus, arsenic, antimony, bismuth. So these are all remaining elements. Remaining elements are solids. Remaining elements are solids. Okay, nitrogen only available in the form of gaseous state. Okay, and you see nitrogen and phosphorus, these two elements are, okay, non-metals. What are they? Nitrogen and phosphorus, these two elements are, what is that? Non-metals. It's not a metals. And arsenic, antimony is the metalloids. These are the metalloids. Bismuth is a metal. Bismuth is a metal. Okay, now what we are discussing? Physical properties. In the physical properties, the one more important point, what is that, you know? Their melting and boiling point. You remember, boiling point down the group increases. Boiling point, what happens? Down the group. Boiling point down the group, what happens? Increases. Boiling point down the group increases. but melting point only, the little difference, anomalous property will be shown. Nitrogen, phosphorus, arsenic, up to arsenic it will be increases. Then after antimony, bismuth, from arsenic it will be decreases. What I'm telling you, understand? Okay. The melting point up to arsenic increases, then after decreases. Okay. This is the melting point. Okay. And you remember, these all elements are forms the allotropes. The important part. And these all elements are forms allotropes. Okay, so this is the physical properties about the fifth group elements, right? And then we are going to discuss about the chemical properties. Chemical properties. In the chemical properties, we are going to discuss about the oxidation state and trends in the chemical reactivity. First one, we are going to discuss about the oxidation state. Okay, now see, these all group elements, all fifth group elements, common oxidation state is that -3, +3, +5. What is the common oxidation state of these fifth group elements? -3, +3, +5. Okay, right. And you remember, the stability of -3 oxidation state is decreases down the group. Stability of -3 oxidation state decreases down the group. As well as +5 oxidation state also, +5 oxidation state stability also decreases down the group. Decreases. Why decrease, you know? Here the very important phenomenon which is involved, that is inert pair effect. What is that, you know? Inert pair effect. So what is inert pair effect, sir? See, actually these are fifth group elements. Fifth group elements is general electronic configuration Ns2Np3. See? Fifth group elements general electronic configuration is Ns2Np3. Means in S orbital already paired electrons are there, and P orbital 3 unpaired electrons are there. Okay. So what is the inert pair effect means? Ns2 electrons are not participate in the bonding. Ns2 electrons are not participate in the bonding. That phenomena is known as inert pair effect. Okay. So that's why only P electrons are involving. P electron, how many? 3 are there. So that's why +5 oxidation state stability decreases, -3 oxidation state also decreases, but +3 oxidation state is increases. This point you remember. Okay. -3 oxidation state stability decreases. +5 oxidation state stability decreases. +3 oxidation state stability increases. Okay, and you remember, +5 oxidation state is exhibited by only BiF5 molecule. Only BiF5 molecule only exists. Okay, right. And one more important point here: nitrogen along with -3, +3, +5, which is exhibit +1, +2, and +4 also exhibits. I'm telling you know, nitrogen which is exhibits along with -3, +3, +5, +1, +2, +4 also which is exhibits. Okay, right. And nitrogen exhibit a +5 oxidation state when nitrogen is combined with oxygen only. Oxygen, not even a halogen also. Just to ask, nitrogen will exhibit +5 oxidation state? Yeah, yes, I'll exhibit +5. When I'm going to combine with oxygen, give one example. N2O5, I will not see N2O5. An acid, and a solid. In my N2O5 molecule, I'm going to exhibit +5 oxidation state also. Okay, right. And nitrogen, along with these oxidation state, +1, +2, +4 also exhibits. Right. And you know that this nitrogen molecules stabilized by the disproportionation reaction. So what is the meaning of that? Okay, I'll tell you, see, the important point here. Nitrogen molecule exhibit the, different to variable oxidation states. -3, +1, +2, +3, +4, +5. Mean the nitrogen molecules which is able to formation of multiple or variable oxidation states. Due to that oxidation state which is undergoes a disproportionation reaction. And the nitrogen molecules is stabilized by the due to disproportionation reaction. And means those oxidation states. Okay. Now see one example I am going to take the disproportion reaction of nitrogen. 3 moles of HNO2. This is a nitrous acid. What is this? This is a nitrous acid. The nitrous acid undergoes a disproportionation reaction that comes into nitric acid plus water plus NO. Okay, this is a nitrogen disproportionation reaction. Hello, sir. First, tell me what is a disproportionation reaction. You don't know? What is a disproportionation reaction means? Okay, in the molecule, one element. Now you see what is the oxidation state of this element is the +3. One element is undergoes 2 oxidation state here. These are +2. It means that nitrous acid +3 to turn into +5 and a nitrous acid +3 to +2. So one element to +3 to +5. What happened here? Oxidation state is increased. That's why it is undergoes oxidation. And +3 to +2, which is oxidation state, is the decreased. So that's why this is the reduction. This is the reduction is the takes place. So one nitrogen element exhibits the 2 oxidation states here. See the products. So that's why this phenomena is known as a disproportionation reaction. And the nitrogen oxidation states are stabilized by due to disproportionation reaction. Okay, right. And then next you see phosphorus. See, these all group elements of common oxidation state is a -3, is a +3 and +1. Along with the phosphorus also exhibit another 2 important oxidation state. Those are +1 and +4. Okay, phosphorus also undergoes a disproportionation reaction. For phosphorus also undergoes disproportionation reaction. So give one example, sir, for phosphorus. Yeah, I'm going to give an example. See, P4, white phosphorus. This is the white phosphorus, P4. P4 is reaction with 3 moles of NaOH plus 3 moles of H2O. These was to BH3 plus 3 moles of NaH2PO2. Sodium hypophosphite is found. Sodium hypophosphite. See, phosphorus oxidation states also stabilized by the due to formation in the disproportionation reaction. Now see, your P4 molecule oxidation state is the 0. PH3 molecule oxidation state is the -3. And your phosphorus oxidation state is the +3. Now see, phosphorus oxidation state 0 to -3. Oxidation state is reduced. So that's why this is undergoes reduction. Okay, here oxidation state 0 to +1. Oxidation state increased. It means what is it? Oxidation state is increased. It means which is undergoes oxidation. Okay, you got the point. So phosphorus molecules also undergoes a disproportionation reaction. And then oxidation state stability by the disproportionation reaction. Okay, sir, one doubt. The remaining arsenic, antimony, bismuth, these are not undergoing. Yes, those are also undergoes a disproportionation reaction. Okay, right. All are undergoes disproportionation reaction, but we have taken the example for nitrogen and phosphorus only. Okay, right. So this is the oxidation state. Okay. Then now we are going to discuss about the anomalous properties of nitrogen. This is very important. Anomalous properties of nitrogen. Okay. In the anomalous properties of nitrogen, means nitrogen shows us some different properties compared to same group of other elements. When nitrogen telling to the other elements, The nitrogen telling to the other elements of same group, phosphorus, arsenic, antimony, bismuth. What it is telling, nitrogen telling, hey, Mr. Phosphorus, arsenic, antimony, bismuth, come back to you. I'm a small size. I'm a small size, and I'm having the highest ionization potential. And I'm having the highest electronegativity. But I'm not having the unavailability of the orbitals. I'm not having the orbital. That's why the covalency of nitrogen is equal to 4. So covalency. What is the meaning of covalency? Covalency is the meaning the bonding capacity of the nitrogen is a 4 only. Just you ask, why nitrogen? Why your covalency is 4? Because I'm not having the orbitals. Remaining all elements are having the orbital. So that's why their covalency is maximum up to 6. My covalency is up to 4 only. So this nitrogen shows some anomalous properties. Okay, here one more point we are going to discuss here. That is a very, very important. What is that? Nitrogen to nitrogen triple bond. To break the nitrogen to nitrogen triple bond, it required 941.4 kilojoule per mole. Yes, when nitrogen telling that my bond dissociation enthalpy is very high. No one can break this bond. 941.4 kilojoule per mole. Phosphorus, arsenic, antimony, bismuth. You know that I'm having the highest bond dissociation enthalpy. Okay, but here these other group elements are what they're telling. Other group elements are what they're telling. Mr. Nitrogen, you are having the highest bond dissociation enthalpy, in the triple bond. You are in the triple bond, you are comparing with the other phosphorus to phosphorus, arsenic to arsenic, antimony to antimony, and bismuth to bismuth. You are in triple bond, you are comparing with the single bond. Then you are telling that you are highest bond dissociation enthalpy. Then you also convert to single bond. Then we will compare who are having the highest bond dissociation enthalpy. So this phosphorus, arsenic, antimony, bismuth is telling to the nitrogen. What they are telling, Mr. Nitrogen, you are telling that we are having the highest bond dissociation enthalpy. In the form of triple bond, In the form of triple bond, you are telling. You are comparing with we all are in single bond. You also convert into the single bond, then we will compare who are having the highest bond dissociation enthalpy. The nitrogen also converted into the single bond. Nitrogen having the very low bond dissociation enthalpy. Low bond dissociation enthalpy. In the single bond, if we compare the nitrogen is the very low bond dissociation enthalpy. Why, Mr. Nitrogen? Why you are having low bond dissociation enthalpy in the single bond form? Sir, why? Because I'm having the non-bonded lone pair of electrons present on nitrogen. Non-bonded lone pair of electrons. See, these lone pair of electrons or non-bonded electrons are present on nitrogen. Due to inter-electron repulsion of these two nitrogens, the bond is clearest very quickly. So that's why in the single bond formation, the nitrogen bond dissociation enthalpy is very low. It's very low. Okay, right. That is the very important point. Okay, and you remember over here, I want to say the important point is that right. What is that? The important point in the total periodic table, catenation capacity having highest catenation capacity is the infinity. That element, you know that there is a carbon. Yes. And nitrogen does not exhibit the catenation capacity. Nitrogen not having any catenation capacity. Why? One day I asked the nitrogen, hey Mr. Nitrogen, you are having the highest electronegativity. You are having highest electronegativity. Okay. And you also formation of the multiple bond. Nitrogen to nitrogen single bond, nitrogen to nitrogen double bond, nitrogen to nitrogen triple bond. That's highest electronegativity. And you also having the small size. Your bonding capacity, covalency is also 4. You are also having non-availability of d orbital. Okay, means that for the carbon having what type of properties? Carbon having what type of properties? All properties are you are having. Carbon also electronegativity is high electronegativity only. And it is also a formation of the carbon to carbon single bond, carbon to carbon double bond, carbon to carbon triple bond. And it is also having the small size. And it is also covalency up to 4. It is also unavailability up to d orbitals. There is no d orbitals. So carbon having this, whatever the properties are there, even you know that. Carbon also formation of the p pi bond. You are also forming the p pi bond. Yes. Okay. Carbon, what type of properties are present? All properties are you are having. But why? What happened? Why you are not exhibiting the catenation capacity? Why tell me? Why you are only diatomic molecule? Only N2 only 2 atoms are. Why you are not exhibiting catenation capacity? If you ask, it is telling that only one reason, sir. One problem, only one problem, sir. See, what is the difference? You know, carbon not having the non-bonded electron on it. See, it means that carbon formation of the bonds not having the non-bonded electrons on lone pair of electrons. Okay, if a carbon to carbon bond is found, that bond is a very strong bond. Very strong, up to infinity catenation capacity. So if I form what happens, nitrogen to nitrogen, if I form this type of catenation, what happens now? I'm having a non-bonding electrons here. So this non-bonding electrons inter-repulsion is going to take place. Due to those inter-repulsions, the bond is going to weak, sir. It's going to weak and it's going to break. So that's why I'm not able to exhibit the what? Catenation capacity. Okay, so this is a very important point of anomalous properties of nitrogen. Okay, right. Yeah, and the next important point we are going to discuss. Here I told you one point, nitrogen exhibit the p pi bond nitrogen. See, p pi bond exhibits. The nitrogen exhibit the p pi bond. Other group elements does not exhibit the p pi bond. And the nitrogen exhibit the p pi bond along with the nitrogen to nitrogen, or nitrogen to oxygen, or nitrogen to carbon also exhibit the p pi bond. But other elements, p pi bond does not exhibit. Other elements are exhibit the d pi or d pi bond is exhibits. Okay, right. Sir, what is the meaning of p pi, sir? P pi means, sir, it means that in between two atoms, two p pi orbital, mean px and py orbitals are involved and formation of the pi bond. Okay, there is a p pi. And other elements are p pi is not possible. Okay, but for example, see, phosphorus is exhibit the d pi and p pi bond is going to exhibit d pi p pi. What is that? D pi p pi. C has taken 3, phosphorus exhibits, and C has 3 taken 3. E double bond CH. So in this form, phosphorus exhibits the d pi p pi bond. D pi. Okay, and in the form of C2H5 taken 3 phosphorus and C6H5 taken 3 in the form of arsenic. Other group elements are, so these molecules, this type of molecules with the transition elements, forms, what is that, this type of elements with the transition elements forms, what is that, D5 bonding also. What is that? D5 bonding also, it will be formed. Okay, so this is the anomalous properties of the nitrogen. Okay, right. And the next we are going to discuss about the reactivity towards the hydrogen. What is that? Reactivity towards the hydrogen. Reactivity towards hydrogen. So reactivity towards the hydrogen, these are EH3 type of molecules are included. EH3 type of the molecules. So EH3 type of molecules means NH3, PH3, arsenic H3, antimony H3, and bismuth H3. These type of molecules are will be formed when the nitrogen or these all fifth group elements are going to reaction with the hydrogen. And use, remember that some very important properties are will become, and these compounds, these all compounds, acidic character down the group, acidic character down the group increases. Acidic character down the group increases. Thermal stability decreases. Means thermal stability least is the highest. Bond dissociation enthalpy also. Bond dissociation enthalpy also decreases. Bond dissociation enthalpy decreases. And the next you see basicity. Basicity decreases. The decreases. Acidity increases. Thermal stability decreases. Bond dissociation enthalpy also decreases. Basicity decreases. Okay. Finally, reducing nature. What happened? Increases. This is the increases. Reducing nature increases. Ammonia is the mild reducing agent. But bismuth is strong reducing agent. And finally, the boiling point. The boiling point order is a very, very important boiling point order of this. You remember, compared to PH3 and arsenic H3, ammonia having the highest boiling point. The reason is that, ammonia going to formation of intermolecular hydrogen bond. Due to intermolecular hydrogen bond, ammonia is highest boiling point is going to exit. Okay, so now boiling point order, just to remember, nitrogen, phosphorus, arsenic, antimony, bismuth. Then this is the nitrogen. This comes middle. It's a middle is here. Here it came. Here it is came. This is the middle. This one. Now say from here. Nitrogen came here. Phosphorus, arsenic, nitrogen mean ammonia, and antimony, bismuth. So ammonia is comes the between of here two elements, here two elements. In the boiling point order, not only PH3 greater than, arsenic H3 greater than, ammonia greater than, antimony greater than, and bismuth. This is the, what is that, boiling point order. That is you have to remember. So why ammonia is high means already I told you intermolecular hydrogen bond, and along with these properties also you have to remember. Okay, right. And the next we are going to discuss about the reactivity towards oxygen. reactivity towards oxygen. Okay. See, this fifth group elements have reactivity towards oxygen. Then formation of two type of oxides. One is the E2O3, one is the E2O5. Two type of oxides are in between. Okay. And you remember, in these two, your oxygen state is the +3, your oxygen state is the +5. In the form of U2O3, the central atom oxidation state is a +3, E2O5 +5. In which form oxidation state is high, those molecules are having the covalent character. Means this is having the covalent nature, high covalent character. This is also low covalent character. Okay, oxidation state increases, covalent character also increases. You remember. Okay, and one more important point, in the form of U2O3 and U2O5. In the form of U2O5, all are acidic character, having all are acidic character. But in the form of U2O3, nitrogen and phosphorus oxides are purely acidic. Okay, and arsenic and antimony are what is it? No, amphoteric nature. Amphoteric nature. Where in the form of E2O3, like N2O3, P2O3, purely acidic. S2O3, Sb2O3, amphoteric. And bismuth oxide, these are predominantly basic. What is that? This is the basic. In the which form? U2O3 form. U2O5 form. All are acidic. Okay. So you remember this is an important point here. There is a reactivity towards the oxygen. Okay. Right. And the next we are going to discuss about the reactivity towards a halogen. Reactivity towards halogen. Yeah. See, these are going to reactivity towards a halogen, then formation of EX3 and EX5 type. How many types? Two types. One is the EX3 type, another one EX5 types. Okay. In the form of EX3 type, EX5 type having the more covalent character. Okay, and here the important point you remember, nitrogen, okay, does not form EX5 type. Nitrogen does not form EX5. Yes, sir, I am not from the EX5 type. Why? Because I am not having the d orbital, unavailability of d orbital. I am not having, sir. That's why EX5 not found. Even EX3 type also I am not found. And in the form of nitrogen is telling that, sir, you know what the secret is that, you know the secret? EX3 type also I am not having the stable compounds, sir. Only the stable compounds are NF3 only. NF3 only unstable, sir. In the form of NF3 only unstable. Other explosive, sir. Those are explosive. I'm not able to stable in the form of EX3 also. Okay, so but other elements of the same group, phosphorus, arsenic, antimony, those are going to stable. In the form of EX3 as well as EX5. So because they are having the availability of d orbital, but I am not having. So that's why. So this is the reactivity towards halogen. And the next we're going to discuss about the reactivity towards metals. Reactivity towards metals. And these elements are reaction towards metals. Then formation of, okay, what is that you know? The nitrogen, phosphorus, arsenic, antimony, bismuth. The nitrogen, Ca3N2, Ca3P2, Na3As, Zn3Sb2, Mg3Bi2, calcium nitride, calcium phosphide, sodium arsenide, zinc antimonide, magnesium bismuthide. Magnesium bismuthide it will be found. Okay, so you know the important point. In these all metal reaction, we are going to reaction with metals. Here, the nitrogen, phosphorus, arsenic, antimony, bismuth. These are all elements, fifth group elements, oxidation state. What is that? -3 oxidation state. What is that? -3 oxidation state, -3. Okay, so this is the chemical properties of fifth group elements. Okay, and the next class we are going to discuss about the important compound of fifth group elements. Then we'll discuss. Okay, thank you. Bye bye.